Hello, a look at chemistry now and a look at rates and rates of reaction. Right, okay, so sometimes in a chemical reaction you get a gas given off, and what happens is your mass value decreases or the volume of gas increases. Okay, so if we have a known mass of liquid in here and we add a chemical into that liquid, they may react together and form a gas. And what would happen on the scales is the mass of the two added together would start to decrease as gas is added into the surroundings. Also, you may mix together two chemicals in a conical flask, and if you do that, a gas may be produced, and you may collect the amount of gas in a gas syringe. So what you are looking at is you are having a look at the change in mass, or you're having a look at the change in volume. Now you can calculate how quick your reaction is by doing the mean rate of reaction is equal to the amount of reactant used divided by the time taken. Okay, it is also acceptable to have amount of product. Okay, use either or. Okay, so if we've got mass divided by time, then the unit would be grams per second, and if we've got volume divided by time, that would be meters cubed per second. Depending on what it is, it could be centimetres cubed per second, of course. So in this reaction we've got a mass decrease, and eventually it stops at this point where the mass does not change. If you are asked to calculate the rate of reaction using the graph, okay, let's say you're asked to calculate the rate of reaction at this point, then what you would do on the curve is you would need to draw a tangent, so we make sure that the line hugs the curve as best as we possibly can, and then what we would do is we would do a gradient calculation based on that. So that would be grams, that would be seconds, and we calculate grams per second, and that is how we calculate rate of reaction.